Okay, so this chapter 11 is on the basic display modes. Um, this covers A mode, brightness mode, and motion mode. There are some other modes that we might want to think about, and that's like color Doppler and pulse wave Doppler. Those are different modes also. So these are going to be the three basic modes of display, uh, just the A mode, brightness, and M mode. So A mode is what we call amplitude mode. And if we look at this slide, this is an amplitude mode up here of a artery, um, where we're looking at the wall of the artery, then the fluid within it, and then the far wall of the artery, followed by some fat beyond it. It doesn't look like a image that you would think of, but what this represents is our um, one scan line through our image. So if we just sent out a pulse and we got echoes back along this path, that's what this is. This is the echoes returning from one scan line, one pulse of ultrasound. So we send out a pulse, it hits a strong reflector here. You can see the sharp echo that returns. It passes through the still a sharp echo until we get to the backside of it, and then the echoes begin to diminish in strength. And then it hits an anechoic area where there's no echoes being returned. And then it hits another sharp echo. And then past that are some uh, echogenic material that is of varying brightness and it's attenuating. It's getting weaker as we go deeper, and then it's a dark structure at this point, and then moving upward, another bright wall here, and that just slowly fades off into darkness on our image at the far deepest portion of the image down here, where we're getting very weak echoes back. This is called amplitude mode. This is what each scan line is based on. So when we say that we spent that time listening for return echoes, these are the return echoes that come back to us. And then we're going to plot them on our B mode, brightness mode, as levels of brightness. So this would be a very bright echo up here in the A mode. This would be a very dark echo down here in the A mode. So varying levels of brightness or grayscale in our scan line. So B mode is also known as brightness mode and grayscale mode because these echoes will be varying levels of gray. Now M mode is when we keep a cursor along one portion of our 2D brightness mode image, and then we measure the echoes as they change over time, thus showing anything that's moving. So this is a fetal heart. We're taking a slice through the fetal heart along one scan line of the B mode image and showing how that heart is changing over time. So we see the ventricle contractions coming together and spreading apart and coming together. You can actually measure the change in the ventricular diameter along that scan line when you do a image like this. So we see up on top here, we see in this case, the fetal left ventricle on top, the right ventricle on the bottom, and you can see how they change over time. So M mode is known as motion mode, B mode is known as brightness or grayscale mode, and A mode is known as amplitude mode. Very important things to remember. So A mode represents a single scan line. It appears as a series of spikes The vertical height is the amplitude of the returned echo. The horizontal location is the depth of the echo. Strong echoes create very tall spikes. Weak echoes create short spikes. So this is a short spike right here. That's a weak echo. This is a tall spike here. This is a strong echo. Here we see a strong echo in the middle of these two, and then another weak echo. So in this case, we go strong echo, weak echo, strong echo, weak echo, strong echo. All right. This is used for, it is very accurate for measuring depth because you can measure the distance between these strong echoes. And they still use it today to measure the thickness of the lens in an eye in order to determine what size artificial lens should be used to replace a cataract. So it's still used in ophthalmology today, this A mode imaging. Normally, though, A mode imaging is converted into B mode imaging, and so then we're able to excuse me, we take our A mode imaging and we convert it into B mode so that you can collect information in grayscale because we like pictures of things. And so that's what B mode gives us is pictures of things instead of spikes. So with B mode, we place the dots on the screen as varying degrees of brightness. We put multiple scan lines together, one right next to the other to form an image. When we talk about real-time B mode, so this is called a static scan in the middle here. This is an old static scanner on the left. And they were very difficult to work with, but they gave us our first grayscale images. Okay, so you'll hear these called static scanners or B scanners sometimes. They gave us our first B mode. Anyhow, with real-time B mode, the pixels are there we go. Real-time motion is not going to work right now. Anyhow, the pixels appear on the screen with normal brightness, and this is the viewing mode that we're used to seeing when we're scanning today. The brightness of each dot indicates the signal strength, and strong echoes are displayed as brighter dots, and weaker echoes are displayed as darker dots. The choice of strong echoes being bright and weak echoes being darker is purely arbitrary, and on most machines you can just push a button to invert that so that the weak echoes are bright and the strong echoes are dark. In motion mode, again, as I was saying before, we're looking at things that are moving over time. So in this case, we're seeing a heart in the center of our image, and a single scan line is taken, and along that scan line we show the changes that occur by the reflectors over varying depths over time. So the horizontal axis is time, the vertical axis is depth. In the A mode, as opposed to that, the horizontal axis is time, and the vertical axis is brightness or signal strength. Okay, so let's go back to that. All right. So in this case, a single scan line is shown changing with time. And we can do that with a lung example. So here is a picture of a lung, an M mode of a lung. We see the near field muscles, and then we get to the pleural space and we see the reflections of the lung that occur from breathing, how the changes from muscle tissue to lung tissue. And this is known as the marching ants view down here. And then we get to a point where instead of seeing the lung tissue behind the M-mode, if the patient lets out their air, the lung moves up and there's a pneumothorax. So the pneumothorax has moved into view over time. And so we can see in time exactly the point where patient breathing is showing a pneumothorax. And this pneumothorax is just more reverberation echoes. We'll talk about reverberation echoes eventually. So our display modes are A mode. The x-axis shows you depth or time. The y-axis shows you amplitude. There is no z-axis. In B mode, the x-axis is depth. The y-axis, there is none. And the z-axis is considered brightness level, so the brightness of it. In M mode, the x-axis is time. The y-axis is depth. And the z-axis or brightness level is also the brightness level, the amplitude. You can see on M mode, you do see the brightness level, even though this summary by Edelman says that you do not. Okay, that concludes chapter 11.